Okay, so the idea for term paper is very simple. Term paper are generally being given to PG students to enhance their technical writing skills. Okay, and second is oral presentation skill, as well as critical thinking skill. So basically, term papers are nothing but you will be reading maybe 15, 20 papers, probably 2, 3 books, and certain monographs or technical reports published by quality universities or certain research group. Technical reports will include thesis also, as well as certain project report or simply report. Sometimes various research groups simply publish these uh, project reports or technical reports or notes, whatever you can call it. So what will be happening is that in this mid semester break, I will assign one term paper, maybe a group of 2 students, or individually also. If I'll have sufficient number of term papers, I'll assign individually also, or I'll assign the so-called group basis also, two in each group, and I'll give you one topic. In that topic, so based on your understanding that we will finish it up in maybe in by the end of October, you will be equipped enough to explore these papers, these books, these monographs, these technical reports related to this topic. I mean, let's say, for example, if I've given you topic on, you know, error propagation in non-linear model. For example, I'm just giving one example. So error propagation for non-linear models is a very generalized topic. What you need to do, although the topics would that I would give you would be more research oriented as well as the field oriented, where you will going to be working on. So the topic that I'll give you would have major impact towards your uh, future works, as well as they will be given in a such a way that you will improve your writing skills, because in BTech nobody would writes that much at that much level that could be used in so called or that could be called as a technical writing content. So you probably do not have the skills, that much skills to present your content in a better manner. Then some of you may be weak in speaking at the technical content, how to deliver a presentation, because many of you would have been working right now up to in a group where the leader is speaking in front of a committee. Generally you just step back and think that since my leader is presenting, I no need to present myself also. So oral presentation is very critical part of what should I say, the uh, for a PG student, as well as the critical thinking, how your mind is actually thinking when you are talking about a particular subject, how well you have imbibed the knowledge, as well as how well you have read those papers which you have taken the reference for. So you will be presenting a PPT, and you will be writing a 4-page double column report also in IEEE format. See, if you think in that direction, your institute offers 10,000 rupees for support to student participating in national and international conferences. And many students, they think that we will do this kind of work in next semester. But if you have explored good in certain term papers, you have the chances to publish your conference paper also. And for that, uh, writing is very important, and that's why IEEE double column 4-page content is very good enough to enhance your writing skill, as well as get accustomed to how the conference paper or technical journal articles are written. Okay? So your objective would be to present a PPT of 20 slides, maybe 20-25 slides based on your term paper, as well as you will have to submit the 4-page double column report. Okay, where the moment you follow these papers, these books, these monographs, these technical content, you will eventually know that how the paper are generally drafted, what are subsections that are focused on maybe abstract, introduction, background, literature review, the particular subsections in the methodology part, then summary of results, conclusion, observation, such type of headings that you would follow. And these term papers will be of 15 marks. That means out of your 100 marks, we will evaluate you by 15 marks. So 5 marks for your presentation and 10 marks for your report writing. So how well you are writing, so you will be scoring in these 15 marks. Okay, so I mean, obviously, you will be given the topics soon as I'm finalizing it. The probably by the end of this next week, you will be given these topics, and you will be having 1.5 month, complete 1.5 month. That means completes November as well as part of your last 10 days of October also. Then by these in these 1.5 months, you will explore the paper, you will read the content, you will follow the articles, as long as you are developing your understanding in this course. Please remember, as a PG student, your responsibility is to explore beyond your classroom teaching. That is your one of the major responsibility. Please do not think that this would be as usual as your BTech course where teacher is teaching everything and you are just sitting in silence and just listening. That would not help you in any way. As a PG student, your job is to explore beyond your classroom teaching so that you would enhance your career domain as well as your overall personality. You could improve as long as you are aware about more technical content. Okay, so the topics would be given in such a manner that your classroom teaching would help you as a support, as a background, but eventually you have to devote little more time to think in those in those papers or reference which you are following, where you will get enough idea that what is really happening in a certain domain, how you could contribute, what are your observation on some significant papers. Okay, so your results, I mean your analytical thinking would be evaluated based on how well you have observed the methodology, how well you have seen that results which are coming in the paper is sufficient enough to you to be presented, as well as what are the critical points which are missed in that paper. So that's how you will evolve yourself. Okay, because if you see other universities, maybe in US or Europe universities, the examination, I mean in PG level, the examination which you call it as a mid semester examination or end semester examination, the weightage is generally only 15 to 20%. That means their curriculum demotivates such kind of examination where we are going for mid semester memory based examination or end semester examination. Instead, their more focus is towards what should I say, the mini projects, term papers, the so called as group discussion, as well as the so called as surprise quizzes, where you will be evaluated based on the content learned in a lecture. So believe me, these kind of mid-semester and term paper percentage, which are very high in India, is very low in other universities. 35% is given to term papers, mini projects. Then the 20% for mini project or assignments. Such kind of percentage are distributed. So objective is very simple, that PG students are not supposed to be stick to only classroom teaching. They have to think beyond the classroom teaching. So the similar objective is applied here also. That's why we have, from past several years, we are introducing these term papers where students are supposed to present in a group as well as a single topic also, if the strength is not that much, and you will be, I mean, you will feel good because when you will be exploring these areas, you would come out as a something which you should be proud of. Okay, so that's how our so-called term papers would be given. I'll assign term papers as soon as I'm finalizing the list, and uh, obviously in after mid-semester break, uh, you would be reading those papers. Your TA will assist you. I'll ask Shivika to have one discussion with you, with all of you, so that you could be briefed about how the term paper is presented. So do not worry. I mean, you will be all given certain hints in terms of paper reading, as well as finalizing your content, as well as preparing your slides also. So, but again, I mean, you have to be prepared well enough to ask questions. What are your thoughts? What are your doubts? Only then we'll be able to help you out. Okay. Yes, Sumit, you were asking something.
Yes, sir. My marks you did not tell.
You did not. I have not announced your marks.
Yes, sir.
Okay. Sumit, you have got 13 in quiz 1, and you have got 19 in quiz 2.
Sir, my marks also.
Abhijit, I have told you, you have got 12 marks in quiz 1 and 16 marks in quiz 2.
Sir, I'm currently in hospital, so I can't attend the class.
Who's Abhijit?
Sir,
Abhijit, you?
yes, sir. Yes, yes, sir.
Okay, no issues.
Thank you, sir.
Okay, so we are just moving on with our new topic. That means, and I hope you have submitted your assignment by now. I think the the deadline for assignment is closed. All of you have submitted it.
Yes, sir.
Good,
Yes, sir.
Yes, sir. Yes, sir.
Yes, sir.
Yes, sir.
good. That's good. And I mean, obviously, needless to say that you have, I mean, grabbed all the concept of probability of basic probability as well as error propagation, because submission of assignment is not a, I mean, just part of that process which we eventually have to learn together. Okay, so ultimately we are moving towards advanced content of the course, where we will try to learn about adjustment steps and the need of adjustment, but at the same time it is also expected that you have very well grabbed those basic concept which I have been which I have taught in your elementary basic concept of probability, and as well as the error propagation. Okay, so having said that, let us. I'm just sharing the screen for your content which was remaining in that previous class. Okay, so we were, I mean, discussing about the error propagation. Last we have finalized this, where we summarized our whole discussion, in this steps, as we will read this problem, we'll form the mathematical model, and then we'll see, look for number of variables in the problem. That value of the variables or observable would be assigned in a function called mu plus minus sigma, so that you know what is mu, what is sigma. And then based on mu and sigma, you will quickly form the Jacobian based on the number of functions as number of variables. You could form it. That would have component as partial derivatives, which would be evaluated with respect to mu. And you can have the error value, which is based on linear or nonlinear function. You could have it. So that was the summary we have discussed it. Okay. So that's the end of the error propagation. Now the next concept is balancing of accuracy. Okay. So in the case of balancing of accuracy, our objective is to first tell you what is the objective of this balancing of accuracy. Obviously, the content could be, you can follow from Mikhail and Gracie, the detailed content. But what I'm telling you is the requirement. What is really happening in real world scenario is that what is the process that I must tell you in geoinformatics. What is really happening? The client would come to you as a geoinformatics professional, as a client would come to you and will give you the problem that, okay, see, Mr. So and so, my problem is to do this or to find out this. Now, as a geoinformatics professional, your objective is not to just tell him that whether you could achieve the desired objective or not, but at the same time you must also tell him by mathematically or by logically that whether this kind of task is possible or not. Now, this is very unusual scenario that generally whenever you get a task or get a kind of work, you try to grab it, but somehow in this field limitations are always there. You cannot eventually just say yes to everything, because there are certain levels of limitations which you need to be aware of. And for that matter, let's say a problem is given. Okay, a problem is given like this. You just read it. The problem says the height h of a survey station A, or maybe any tower A, or any light tower A, or any chimney or any pole, whatever it is, the height h of a survey station A above the instrument center at B is to be determined with. Now, this is your client task, which he is telling you that the height has to be determined with a standard deviation of 0.010 meter. That means he wants that sigma h to be 0.010 meter. Okay. From measurement of the slope distance s, vertical angle alpha, and the target height at h. Sorry, target height as t. Now, you must consider this problem from error propagation point of view first, that you are given a function that is nothing but h plus t is equal to s sine alpha. That means this is the height, total height, which is h plus t, is count as s sine alpha. If you have s and you have alpha, that's how you will solve it by your basic adjustment computation point of view. Okay. Now, what is really important is when you are doing this. Okay, when you are doing this in error propagation, you generally estimate the sigma h, isn't it? Sorry. In your error propagation, you generally estimate the sigma h by knowing the errors in three fundamental quantities, which is s, alpha, and t. But in your problem of, or in the given problem, the client has given a deadline, or a tolerance that the sigma h has to be this much. He cannot accept any larger sigma than this. That means he has to. He is very precise with his final deliverable. Okay, just like you go with the to tailor for getting some new dress or and then you will be very precise that do this kind of measurement, do this kind of measurement, I want this kind of fitness here, and you are very precise, and sometimes your tailor can say that it is not possible to have such kind of fitness because if you it could get tightened up here if you lose it up here, such kind of issues. This is one raw example. Similarly, if you are constructing a house and if you are very particular about finishing certain things, so the worker or the supervisor will instruct you, tell you that it is not possible, that these are the limitations which are there. So similarly, in our case also, whenever we are assigned a task, the final deliverable, that means the final value which we have to estimate, is something which is defined that you have to have the sigma of this final value as this much. Now, what is really happening? You have to be logical enough because you are well aware of about instrumentation. You are well aware about of your task accuracies which you have achieved in the past. Now, what you have to do? You have to tell him logically, and when I say logically, that means mathematically, that whether your office or your firm is capable enough of achieving this kind of sigma or standard deviation in the height measurement which you are demanding. Now, my question is how and what are the factors which should be involved here? I mean, if you logically think, you could get the answer. Just let me know the involving factor in decision making, that whether you should accept this challenge or not. बताइए. बताइए भाई. आलोक.
Yes, sir.
प्रॉब्लम अगर आपको दोबारा सुननी हो तो मैं फिर से रिट्रेट कर देता हूँ, बट योर पार्टिसिपेशन ऑफ in answering those critical questions is very important. Then only I'll be able to understand how much content you are absorbing. बताइए. हम्म.
Sir, please elaborate one more time.
See, let us just ask someone else also before. Bhagat.
Yes, sir.
बताइए. राहुल आप बताइए।
यस सर।
बताइए।
सर एक्चुअली प्रॉब्लम सर रिपीट कर दीजिए सर।
यार हम पूछते हैं तब तुम बोलते हो। खुशी आप बताइए।
यस सर।
बताइए।
सर एक बार फिर से बता दीजिए, नहीं आया।
वो तो हम बताएंगे बेटा, कुछ आंसर आप भी तो बताइए। इतनी देर से हम बोल रहे थे, आप लोग कुछ समझ ही में नहीं आया क्या? सुमित।
सर फैक्टर्स इन्वॉल्व हो सकते हैं सर कि जो एंगल मेजरमेंट है उसमें कितनी क्या हमारा एक्यूरेसी है, और सर जो हम डेविएशन इसमें निकालेंगे सर वो तो डिपेंड करेगा कि हमारा हाइट ऑफ इंस्ट्रूमेंट हमें क्या मिल रहा है, दैट इज दैट एक्यूरेट और इज दैट समवॉट एक्यूरेट और नॉट, और हम वहाँ से डायरेक्टली उस प्लेस को एक्सेस कर सकते हैं कि नहीं जहाँ से उसकी हाइट को मेजर करना है।
और
और सर उन दोनों पॉइंट्स के बीच की डिस्टेंस क्या एक्सेसिबल है कि नहीं, और सर जो पॉइंट हम एग्जैक्टली मेजर कर रहे हैं वो फ्लक्चुएटिंग नहीं है, दैट इज दैट फिक्स और नॉट, इसमें सर।
गुड गुड गुड, वेल अटेम्प्टेड। और बताइए थोड़ा और कुछ, और थोड़ा सोचिए। वैली शेट्टी आप बताइए।
Sir, here after having this concept, the challenge mainly I'm thinking about the challenge at the height under the first height of that H, sir.
हम्म।
After after analyzing the axis of two places B and A, 2 points, we will get the target height. We can get the target height, but the H should be analyzed properly to get the correct answer.
नहीं, H is the final destination, but you have to follow the process. You have to follow or attempt the basic quantities which are required to get the H. H is indirect quantity, na?
Yes, sir. H is dependent on all these primary factors.
And what else?
सर S and alpha.
Yes. And शिवम आप बताइए थोड़ा। बताइए। क्या हुआ?
सोच रहा
नहीं
था।
गए थे। चलिए, anyone else who want to speak?
Yes, sir.
हाँ बताओ।
सर मीन सी लेवल पे जहाँ हम अपना मतलब इंस्ट्रूमेंट प्लेस करते हैं वहाँ से का नाम जो डिस्टेंस मतलब मेजर करने में, तो उसका हम हॉरिजॉन्टली डिस्टेंस मेजर कर लेते हैं। फिर हम जो थ्योडेटाइट है मतलब जो इंस्ट्रूमेंट में जो भी हम थ्योडेटाइट वगैरह ले रहेंगे वहाँ से उस पोजीशन से मतलब हाइट की एंगल मेजर कर लेंगे। उसके बाद मतलब सर टेक्नोमेट्री लगा के मतलब हॉरिजॉन्टल डिस्टेंस मेजर कर लेंगे। फिर और क्या नाम हॉरिजॉन्टल डिस्टेंस आ जाएगा तो उसमें टेन थीटा मतलब प्लेस करके उसे हाइट मेजर कर लेंगे।
नहीं, ये तो आप जो बता रहे हैं ये तो आप 10th लेवल वाली चीजें बता रहे हैं। हम क्या पूछ रहे हैं आपसे, आप क्या बता रहे हैं? वो तो मैंने मॉडल लिख दिया है आपको, वो तो मेजर कर ही लोगे यार, उसमें क्या नई चीज है। मैं पूछ रहा हूँ, see this problem is not from trigonometrical point of view, this problem is from your commitment. Yes,
The standard deviation of alpha is limited. That could be a major challenge of an
well,
instrument.
you do not read these right now. अभी तो ये सब special cases है. What I am trying to ask you, what are the factors which you need to still I am not getting the right answer. You do not read this. This is a special case. You are just अभी focused here. हाँ अरुण बताइए।
सर इंस्ट्रूमेंट एरर
ट्राई करूं?
सॉरी,
इंस्ट्रूमेंट एरर सर।
इंस्ट्रूमेंट एरर फॉर व्हाट?
मतलब सर इंस्ट्रूमेंट में एरर है या नहीं, ये कितना
सही से बताइए।
सर मैं ट्राई करूं?
हाँ बताओ।
सर देखिए, अगर मुझे हाइट निकालनी है तो सबसे जो बेसिक है वो तो है स्लोप है, उसका एंगल है, और जो माउंट की हाइट है टी सर। तो ये मेरे पास चैलेंज है, अब मैं इसको कैसे अचीव करता हूँ, क्योंकि वो दूर भी है, वहाँ तक अचीव नहीं हो पाएंगे सर, और स्लोप भी ऐसे इजीली मेजर नहीं हो पाएगा। तो सर सबसे में जो बड़ा चैलेंज है वो है सर दोनों के बीच की डिस्टेंस, माउंट की हाइट, और सर अगर कुछ एक्सटर्नल फैक्टर भी काउंट करते हैं अगर, तो सर क्योंकि सर अगर इंस्ट्रूमेंट है तो सर एक्सटर्नल फैक्टर तो काउंट करना ही पड़ेगा, जैसे टेम्परेचर हो गया, विंड स्पीड होगी, तो सर ऐसा।
So what? I mean, how do you decide whether you are capable enough to go ahead with this project or not? You all have considered the basic assumptions, but you have not
Yes.
decided. These are the assumptions.
हेलो सर।
हाँ,
सर जो हमारे पास इंस्ट्रूमेंट है फर्म में, उनकी एक्यूरेसी कितनी है उसको पुट करके हम मैथमेटिकल मॉडल से अगर एच निकालते हैं, और जो हमारा एम्प्लॉयर है उसे कितनी एक्यूरेसी चाहिए, अगर उसके रेंज में आती है तो फिर हम उसको कंक्लूड कर सकते हैं। और कॉस्ट इसको करने में अगर हमारे लिए फायदेमंद है तो सर।
okay. So yes, partially correct. What I was looking is to when I was saying that you have to decide whether this is acceptable kind of work or not. So basically, to get the h from this function, it is very clear that you must have s, you must have alpha, you must have t. Obviously, this is an accessible area. That means this you can go to that place to establish your station. You can get this t value. You can get the measurement of t. You can get the measurement of s. You can get the measurement of alpha. So what is more important is you are not focused here. You are not focused in those mu, isn't it? You are not focused in these mu's because value would come anything. What is we are more interested in? What would be the error in these measurements? What will be error? Not only single observation. When you take multiple observation, when you have redundancy into the data set, what would be the error in sigma alpha? in angular measurement, what would be the error in this distance measurement, and what would be the error in this T, or which is we call it target height measurement. Because in your error propagation also, if you write the error propagation equation, if y is equal to fx kind of function is available, you write as a sigma yy is Jacobian sigma xx Jacobian transpose, isn't it? But in this sigma xx, you have all input variables, sigma alpha square, sigma s square, sigma t square. In this j, you have simply the numerical value. In this j transpose, you simply have the numerical value. You do not have any function value, isn't it? So how well you know about the errors in the fundamental observables or input quantities, the better would be you would be telling about sigma y. So as a lot of you are hinting it right, that we should not about the instrument accuracy, because instrument could be giving, let's say you have a total station, that total station would be giving I would say better linear measurement but not angular measurement. So what will happen? Will you not take this job? Or you have only linear measurement high accurate device but not angular measurement device, so you will not take the job. Obviously you will take the job, but subject to certain challenges. But the prime challenges is how well you are measuring these sigma in fundamental quantities. Okay, that is first thing. That means how well your instrument can have these values, because ultimately you would be using those values to finally get the sigma h. So primary factor is, are your instrument are precise enough? Because the job is very highly demanding. The job is very demanding. Okay, so you have to be very careful in deciding whether you have that much kind of instrument or not. Second thing, that is first thing. Second thing is, if you have such kind of instrument, when you apply, will you achieve this kind of desired tolerance in the final height estimation? That are the two questions which you have to answer. Obviously, that answers could be given in your office. No need to go to the field. No need to have any kind of supporting, experience. Just by looking at these just a second, I'm just resharing the screen. So in this case, your S will be measured with mu S, sigma plus minus sigma S. Your alpha will be measured as mu alpha plus minus sigma alpha, and your T will be measured as mu T plus minus sigma T. Okay. So suppose you have a very good linear measurement instruments. That means the distances could be measured very well, but you are having very low grade angular device. So what you can do? You can make a trade-off. That means you are improving the sigma T and S so that you can compensate for any low grade sigma alpha, or any low accurate sigma alpha, or low accurate angular measurement. If you increase it, आपके एग्जाम में आप क्या करते हैं? आपके 5 पेपर होते हैं. You have 5 examination, let's say 5 subject. First, second, third, fourth, fifth. If you know that this exam in the particular subject you are not performing well, or you do not have that much confidence to get the sufficient score, भाई आप अपना म्यूट रखिए माइक. So if you are you know You are well aware that in this subject, maybe of geography or physics or whatever it is, you are not that much confident to score high. What you'll do, you score high in these rest of the subjects so that your overall percentage is maintained. That's we do. That's our natural process. That's how we do, isn't it? Similarly here, if you know that my sigma alpha would not be good enough, or I would not be having very much accurate alpha value, obviously we'll improve, so that whatever the best accurate measurement we could do for linear devices. Okay, so for that case, the first case is given for balanced accuracies. The concept of balanced accuracy, that means we consider that all are contributing equally towards sigma h. So we are we are using or evaluate the standard deviation in measuring sigma in S, alpha and T, and we consider the case of assumed balancing. Second case is there when we are aware that our sigma alpha is not that much, or our alpha measurement is not that much great because we have a very low grade instrument. What we will do, we limit our sigma alpha, or we will limit our alpha measurement by certain value, and we reevaluate that how much would be required from uh, sigma t and sigma l. That means if you just simply say that, okay, I'm going to score 50% or 50 marks in one subject. So previously I was targeting for 70 in this subject. I will increase this by 75. I cannot go up for 85 or 90 because that is not my level. But yes, I can improve by 5 marks. I was hoping for 60 marks here, but I will improve by 5 marks. I was hoping for 55 marks. I'll go for 58. I was hoping for 60. I'll go by 63. That's how you improve by in percent, so that you could overcome the 10 marks that you are not achieving here. Similarly, here you are sure that do not have that much instrumentation or high grade instrumentation in your laboratory, so that you could achieve, or you could work with balanced accuracy case. So what you could do, you could limit this case of sigma alpha, and you improve the sigma s and sigma t as much as possible, as much as well precise which you could do. So these are the cases of first, balanced accuracy. That means all are good to go. And second is you limit one, and then you reevaluate. So how would you do it? No, the question is, how would you do it? Because ultimately you cannot simply write in theoretical sense. You have to explain it also. So how would you do? What you will do, you will take the first case, assume balanced accuracy case, and you will write the so-called error propagation is sigma h square is equal to del del h by del alpha, sigma alpha square, plus del h by del s square, sigma s square, plus del h by del t square, sigma t square. That's how you write the error propagation equation. Okay, and then you take the values in these errors, sorry, in these partial derivative, and evaluate it. Do your use your notebook to finally tell me this. What would be sigma h by sigma alpha? What would be the sigma h by sigma s? And you can take the basic measurements which are given. So first case is assuming balanced accuracy. When I say balanced accuracy, it means these three components are contributing equally. These three components, they are, that means this one, this one, this one, three components, they are contributing equally. So when I say equally, so we can write like that: sigma h square is equal to, you know sorry, sigma h square by 3 is equal to del h by del alpha sigma alpha square. Similarly, is equal to del h by del s sigma s square is equal to del h by del t sigma t, because they are contributing equally, isn't it? Now you know sigma h, you know this partial derivative, you are given these mu values. What you can estimate? You can estimate sigma t, you can estimate sigma alpha, you can estimate sigma s. How would you write? Let me just again rewrite here. I can use this side. So I have 0.010 is equal to. How would I write about sigma h by sigma t? Answer would be minus 1 for first case. I'm writing del h by del t, that would be minus 1 and sigma t square. So simply sigma t would be coming as 0.010 whole square divided by 3, because that would become 1. So in this case of balanced accuracy, we produced these results by, so considering sigma, considering the balanced accuracy case, you will get all individual sigma t, sigma alpha, and sigma s. In the second case, when you are telling that your sigma alpha is limited by 5 seconds, so that means here you will put up the 5 second, that means converted to radian. Obviously 5 second you will convert to radian by pi by 180. Whenever you multiply to degree, that becomes radian, and you subtract from sigma h square minus now you get this sigma h by sigma s plus because you have this limiting option of sigma alpha. So now you remove this concept, or from the right hand side you just remove this value, or you get a new compromised final error scenario. Now you can again reimpose the balanced case. Now this will be contributing equally with this, and you can solve, you can get it. So that's how you can decide whether the sigma alpha, which is a limiting factor, how much more you would be doing this. So now I'm giving you a little 5 minutes to solve it on your notebook and give me the answer. Then only I'll share the next page to, so that you could reevaluate whether you have done it right or not. So I'm just giving you a moment, 5 minutes. You just do it. Anyone got the answers?
सर 0.96
Yes,
सर
sir.
फर्स्ट केस का आया है
0.96
फर्स्ट केस का क्या आया?
0.96 सर
फर्स्ट केस का है
फाइनली सिग्मा एस का वैल्यू आएगा सर 0.96
अरे भाई तो तीन वैल्यू
सिग्मा
होंगी
टी
ना?
577 into 10 power minus 3 sigma alpha 3.1 into 10 to the power minus 4 sigma
सब लोग कर निकाल रहे हैं कि बस तुम ही दो तीन
हाँ
लोग
सर
निकाल रहे
सिग्मा टी सिग्मा अल्फा सिग्मा एस ना सर
हेलो
हो? हाँ
सर, सिग्मा अल्फा की वैल्यू 1.66 इंटू 10⁻⁻5 रेडियन और सिग्मा एस की वैल्यू 0.01154 मीटर।
तो भाई इसको रेडियन को उसमें कन्वर्ट कर लो, सेकंड में या डिग्री में।
ठीक है सर।
और सर सेकेंड केस में सिग्मा एस की वैल्यू है 0.00787 और सिग्मा टी की 0.003939।
बढ़ी की घटी? बढ़ा की घटा? मतलब सिग्मा एस की वैल्यू पहले केस से दूसरे केस को कंपेयर करके बताओ, बढ़ा की घटा?
घट गया। पहले में
क्या
सर
शो करता है? What is the physical significance of a reduced value of sigma s and sigma t?
दैट आई डोंट नो।
अरे क्यों? क्या नाम है भैया? नाम बताओ अपना।
शुभम।
क्या भाई शुभम? इससे कैसे चलेगा?
सर वैल्यू रिड्यूस कर गया तो एक्यूरेसी बढ़ गई।
तो कुछ स्टेटमेंट तो दो कि व्हाट डू यू मीन बाय reduced value of sigma? What represents sigma? Sigma क्या रिप्रेजेंट करता है? ऐसे सोचिए ना पहले।
स्टैंडर्ड डेविएशन
What physical quantity is represented by sigma?
स्टैंडर्ड डेविएशन एरर।
Precision.
Precision. Very nice. Do not say accurate or any other word. It is precision. How
Reduced in the
precise your
stand.
observation is. Yes.
Reduced in the standard deviation signifies that the increase good in precision.
Yes. If you are reducing the sigma, it is representing the precision standard of your new data set. That means you are very much in control of data collection process. That's why your sigma s is less and sigma t is more. Okay. So you have to overcome for the low grade quality instrument for angular measurement which you have in your office. अब आप ये देखेंगे that whether you would be able to achieve this new sigma s or sigma t by compromising for sigma alpha. If it is yes, then you can say yes to your client that yes, we'll do it. अब सोल्यूशन आपके सामने है, सब लोग देखिए। जिसका आंसर ना मैच कर रहा हो वो अपना फिर से चेक कर ले।
सर फर्स्ट वाला 0.0115 आएगा ना सर, सिग्मा एस।
Everyone clear? Any doubt? I guess half of the students are computing on their note sheet, so they would be. It is. I mean, good that you should verify your calculations. That is for the balanced accuracy. Now, for unbalanced accuracy, this is a new step which you need to see. Any confusion?
No, sir.
Because everything I have explained in your first sheet, these are all just written in that same fashion. Now you need to do certain, I mean, very basic examples of chapter 7. That means do all the examples of 7.1 section, as well as few initial assignment exercises part, maybe up to 3 questions you could attempt from chapter number 7. Initial examples and few 3 or 4 question initial exercises. Now you can attempt on your own. I'll upload the assignment tab for chapter 7, which you can upload next week. Okay. So I think with this we stop here, because that's the end of the slide also. I mean, we do not have any further content in this particular error propagation. Uh, what we can do, we'll on Thursday we'll start our quest for adjustment, because now till error propagation we understood that error cannot be ignored. If ignored, you have to pay the price in terms of final deliverable. And this is two example that I've given you right now, that how to compensate for those errors which are there in your initial observation. But our main quest is for the adjustment, how well we can deal with these errors, the random errors, how well we can remove it. Sorry, if not possible we cannot remove it, we have to reduce it. What are the steps to reduce it? And in fact, the final solution has to be, I mean, something which is acceptable. At the same time, you have to think of a system or a model where you can simultaneously get the parameters as well as you can adjust your initial raw data, because that is containing the errors. In this problem, what is containing the error? Your error is in the linear measurement, in angular measurement, that is eventually going to H, isn't it? What we have to do? Not only we have to find a system or develop a system or think of a system, formulate a system that can give you H. At the same time, it should also remove or reduce the errors in the primary observables. That is our objective. Okay. So with this, I mean, we stop here. Any questions?